In the quiet that settles before thought, before language, before any human hand reached toward the sky, there was only light. Silent and tireless, it moved across the newborn universe, weaving through the earliest dark, carrying within it a story so ancient that even time itself seemed younger than its radiance. And in the slow whisper of space, where moments stretched into eternities, light became the first witness, an unbroken thread tying every particle, every star, every future life to an origin that still echoes through the void. In the hours before sleep, when the mind loosens its grip on the immediate and the body sinks gently toward dreams, there is a feeling that something old and infinite flows around us. It is not a memory we created. It is a memory we receive. Light, arriving at our eyes from distances we cannot truly imagine, carries more than illumination. It carries the deep remembrance of the universe itself. When we open our eyes to the night sky, we are not merely seeing points in darkness. We are seeing echoes, preserved messages from worlds that may no longer exist. Light folds those messages quietly into the fabric of our perception, allowing us to touch the past without moving. This gentle strangeness, that light travels across unimaginable distances, taking years, centuries, and even billions of years to reach us, invites a question both scientific and poetic. If light has crossed epochs to arrive here, is it not holding something precious? Is it only energy, or is it memory? And if it is memory, then in some quiet sense, every star in the sky is a storyteller, whispering its narrative to anyone who listens. The first illumination that filled the universe did not merely brighten the darkness. It began a continual act of remembering. Before that moment, space was opaque, dense with particles that trapped every spark in an endless struggle. There was no freedom, no vision, no distance, only a restless fog. But as the universe expanded and cooled, photons were suddenly free to travel. The universe became transparent. It was then, in that instant of release, that memory began. The ancient light from that time still exists. It washes across the cosmos, a soft background glow, a frozen diary of the moment creation first opened its eyes. Even before life learned to interpret light, even before organisms developed the structures necessary to receive it, light was still moving, still gathering, still preserving. It passed through clouds of hydrogen, brushed against growing galaxies, and shivered across interstellar dust. Every interaction left a mark, a tiny alteration, like ink pressed onto a page. The universe was writing its autobiography through the language of photons long before there were readers. And yet, light is not just a passive record. It is also a messenger, a traveler that never seems to tire. Photons can travel billions of years without aging. They carry the memory of their origins in their frequency, their color, their movement. A photon emitted from a distant star is a fragment of that star's story. When it arrives here and brushes against a human retina, it completes a journey that began long before Earth even existed. To witness it is to receive a message from the past, not in metaphor but in truth. Imagine standing beneath the night sky, feeling the quiet around you. Somewhere far beyond your sight, a star ignited and began its journey through time. That star may have collapsed eons ago. Its planets, if they existed, may have frozen, burned, or dissolved into dust. Yet its light is still traveling, still holding the memory of when it existed. When it enters your eye, that ancient life continues. In some mysterious way, the star remembers itself through you. There is a profound gentleness in this. Light never rushes. It simply continues, without haste, without fear of forgetting. It moves through distances so large that human language folds in on itself trying to measure them. Light does not demand recognition. It arrives whether anyone is watching or not. It carries no judgment, only presence. It has witnessed everything, from the birth of galaxies to the quiet drifting of dust, and it holds its stories without pride. Somewhere deep inside, humans seem to instinctively know this. We are drawn to light not merely for warmth or survival, but for meaning. There is a reason we look toward the stars when we seek understanding. The distant glow invites us into contemplation, offering the comfort that we are part of something ancient, something that remembers even when we forget. The light that reaches us tonight is older than our languages, older than our stories, older even than the earth beneath our feet. It reminds us that existence stretches beyond the brief window of human time. It tells us that while civilizations bloom and fade, while memories are born and are lost, there is continuity in the universe. Photons, tiny and weightless, carry the epic of creation. The idea that light is memory may at first seem poetic. Yet, in the most literal sense, this is true. Light records the conditions of its source. It carries the imprint of what it encountered, a star's temperature, its motion, its elemental makeup. It tells us how galaxies spin, how the universe expands, how black holes bend the very path of existence. Light allows us to see time itself, not as a metaphor, but as a physical reality. To look into the deep sky is to look backward, to witness the universe's memories unfolding before us. The eye is an instrument of memory as well. Not just personal memory, but cosmic memory. When photons from distant worlds strike the retina, they are transformed into nervous signals, traveling into the brain, forming impressions. The story that began in a star ends as a moment of consciousness. The universe remembers, and through us, it remembers knowingly. In this way, humanity becomes a continuation of the cosmic memory stream. We are interpreters of light, translating the universe's long-journeying messages into meaning. If light is the memory of the universe remembering itself, then we, in our quiet moments, are its dreams. Our curiosity, our wonder, our restlessness in the presence of the stars, these are signs that we are participants in something profoundly ancient. We carry forward the legacy of observation, interpretation, and awareness. As the body rests and the mind begins to drift towards sleep, the idea softens into comfort, that we are surrounded by ancient memories, traveling silently through the darkness, never lost, never forgotten. Light touches us, and through that touch, the universe continues its quiet remembering. In sleep, perhaps we continue that memory. Each dream becomes a soft mirror of the cosmos, luminous and vast. Light within and around us keeps flowing. It is the quiet strand binding all things, holding the stories of stars, of worlds, of life, gently against the silence of time. It is neither beginning nor end, but a continuum, a presence older than thought, a memory older than time. And in this moment, just before sleep takes hold, we too remember.
Before the universe learned to shimmer, it rested in darkness. Not the gentle darkness of night, nor the comforting quiet of sleep, but a dense, opaque state where light could not move, could not breathe. Everything was compressed into a vast and formless stillness. Temperature, energy, and matter were tangled in an indescribable closeness. It was a world without sight, without memory, without direction. And yet, within this primal darkness, the seeds of radiance were already stirring. In the earliest moments after the Big Bang, the cosmos was not the tranquil expanse we know today. It was blisteringly hot, so dense that particles collided constantly. Photons, those tiny carriers of radiance, were trapped. They tried to move, but were immediately absorbed, scattered, redirected. There was no escape. This was a universe struggling to become visible, locked in its own infancy. If light holds memory, then during this era, memory had no freedom. It was confined, unable to stretch outward and tell its story. But expansion has a silent patience. As the universe grew, its temperature fell. The frantic collision slowed. Matter calmed, forming the first simple atoms. Suddenly, light found pathways open. Photons, for the first time, were able to travel without being immediately trapped again. The universe shifted from blindness to sight. And in that moment, radiance was born. This breakthrough is known in scientific language as recombination, the time when electrons and protons first settled into stable hydrogen atoms, allowing light to decouple from matter. But beneath the technical description lies a far more poetic truth. The universe took its first breath. The fog lifted. Light, once imprisoned, was released to roam endlessly. It carried with it a singular story, the moment of cosmic awakening. That ancient light still travels today. We know it as the cosmic microwave background, a faint whisper stretched thin by billions of years of expansion. With the right instruments, we can still detect it, like an afterglow of the universe's first awakening. It is the oldest light we can see, a ghostly imprint from when the cosmos was only 380,000 years old, a mere heartbeat after birth. When we listen to that soft radiation, we are hearing the first memory the universe ever preserved. The birth of radiance transformed everything. It allowed space to become a canvas upon which stars, galaxies, and worlds could eventually paint themselves. Without light's freedom, the universe might have remained forever hidden, a silent darkness without story or witness. But once photons began their journey, the cosmos gained a way to express itself. Suddenly, existence could be seen, not just by future beings with eyes, but by itself. Through light, the universe began to reflect, record, and evolve. This first illumination did not come from stars. They had not yet formed. There were no suns, no galaxies, only simple atoms drifting in a cooling sea. Yet even without structure, the light was full of meaning. It carried subtle ripples, tiny variations in density that would later grow into clusters of stars and vast galaxies. These ripples were the first hints of structure, the earliest signs of cosmic architecture. In their faint patterns, the blueprint of everything to come was already written. It is humbling to imagine that every star, every galaxy, every living being owes its existence to the quiet release of photons in this early moment. When light broke free, it marked the beginning of phase transitions that would eventually allow matter to gather, form, ignite. Radiance was not merely an effect, it was a catalyst. It opened a path for gravity to sculpt the universe, for atoms to clump together, for brilliance to flourish. Perhaps the most poetic aspect of this moment is that the light from that time has never stopped traveling. It has journeyed farther than any being could walk or imagine. It has crossed impossible distances without aging. It has brushed through galaxies, witnessed uncountable births and deaths of stars, and drifted into places no mind will ever see. And still it continues. If we imagine light as memory, then this ancient glow is the universe's earliest recollection, pure, unblurred, untouched by the complexity that would come later. It remembers a time before stars, before worlds, when space was young and unshaped. It holds the innocence of creation, the quiet moment before the cosmos learned to dream. Somewhere within this soft radiance, there is a story of transition, from confinement to freedom, from chaos to clarity. The universe did not instantly become filled with brilliance. Rather, it gently learned to hold light, to allow it to roam. The cosmic dawn was not a sudden blaze, but a tender opening. And like the first sunrise after a long night, it brought with it a promise that the future would be illuminated. There is something deeply peaceful about this thought. Even in its earliest chapters, the universe grew toward expansion, toward openness, toward light. Nothing forced this process. It unfolded naturally, driven by the quiet laws of reality. No sound accompanied it, no witness observed it. Yet when photons finally found their freedom, the universe changed forever. Those first travelers, those ancient photons, carry with them the memory of that transformation. When scientists examine the cosmic microwave background, they are not simply looking at radiation. They are reading a diary written in light. The patterns etched across that glow are the earliest handwriting of the universe, telling of a time before stars, before galaxies, before anything that could know or remember. Light remembers even when nothing else does. And perhaps even now, when we gaze into the night sky, we are humbled not just by the stars we see, but by the invisible light beneath them, the quiet remnants of the universe's first awakening. That soft, ancient glow whispers something gentle, that from darkness, light emerged, from confinement, freedom, from simplicity, the possibility of meaning. If the universe remembers itself, then this was the moment it began to do so. Light became the first memory, the first story, the first witness. And everything that followed, stars, planets, life, consciousness, unfolded in its wake. Light is not simply illumination spreading across emptiness. It is the quiet motion of time made visible. When we look at a distant star, we are not witnessing its present life. We are witnessing its past. We are experiencing a moment from long ago, delivered to us by a photon that has traveled across the patient fabric of space. In this way, light becomes a bridge, not just between places, but between eras. It connects what was to what is, and in doing so, it allows time to be seen, not only felt. Every beam of light that reaches us carries a timestamp written into its being. There is no need for ink or parchment. The memory is encoded in its wavelength, its direction, its energy. Light remembers the temperature of its source. It remembers how fast that source was moving. It remembers the changes it experienced along the way, the stretching of space, the passing near unseen masses, the subtle dimming as it journeyed. It collects these impressions and delivers them intact across unimaginable distances. It is time's messenger. This is why astronomers can speak with confidence about the early universe, even though they were not there. They read stories carried by light. They listened to its frequencies and learned what occurred billions of years before life emerged on Earth. They are able to reconstruct events by interpreting the silent transmission of photons. In the calm darkness of their observatories, they become translators between time and knowledge. There is something tender in the way light keeps these memories. It never rushes. It does not impose itself. It moves forward at a pace defined by nature, consistent and faithful. And although space itself expands, stretching light until its wavelengths lengthen, even this distortion becomes a memory, a testament to the growth of the universe. The redness of ancient light is not a flaw. It is evidence, a soft reminder that time has passed, that distance has widened, that the cosmos itself has changed. When we see a star, we are seeing the echo of its distant past. Many of the stars we know so well may already be gone. Some may have collapsed into silence. Others may have cooled into fading embers. But their light still travels. Their time still shines. The present sky may be filled with ghosts, not in fear, but in wonder, a choir of ancient memories still singing. Light allows nothing truly to vanish without leaving a trace. In our daily lives, time often feels linear, one moment following another, sliding forward like water. But the cosmos reveals a deeper truth. Time folds back on itself through light. Past events, though finished, continue to arrive. They are not lost, they are delayed. Somewhere, the birth of a star is still unfolding. Somewhere, the death of another continues to echo outward. Time, through light, becomes layered. The universe does not simply move on, it carries its history with it. The way light interacts with time is unlike anything else. A photon, traveling at the speed of light, experiences no passage of time from its own perspective. To the photon, its emission and arrival are the same instant. It does not age. It does not change. It is a perfect preserve of the moment it was born. From the outside, we measure its journey in billions of years. But from the inside, there is only now. This strange duality makes light the purest vessel of temporal memory. It is humbling to imagine this. The light that enters your eyes from a distant galaxy began its journey before Earth was formed, before oceans filled, before life took root. Yet from the point of view of that photon, there has been no waiting. It has simply appeared in your world, carrying the imprint of a distant past. You receive, in an instant, a memory that took billions of years to arrive. In this way, light turns time into an active partner. Time shapes the message that light carries, stretching and bending it. But light preserves time's presence, carrying it forward. Without light, time would remain silent. Events would vanish into darkness, leaving no trace of their existence. But light endures as witness, granting time a voice, granting the past a way to be heard. Through this, the universe becomes legible to itself. Light travels between distant corners, transporting knowledge that would otherwise be isolated. A supernova explodes in one region, and its light spreads outward, announcing the event to galaxies far away. In another place, the first atoms form, and their faint glow drifts through space for billions of years until reached by curious minds. Light ensures that nothing meaningful remains alone. Everything radiates outward, sharing its existence with the whole. Even within darkness, light marks its paths. When it bends around enormous masses, guided by gravity, it leaves a signature. We can see how black holes curve time and space because light remembers its deviations. These distortions become maps, guiding us toward invisible forces. Light becomes not just a messenger of time, but a cartographer of the unseen. Sometimes we imagine that memory belongs only to living minds, that remembering requires awareness. But light teaches a different story. The universe remembers not only through minds, but through motion, energy, and continuity. Light is a memory system older than consciousness, older than stars, older than form itself. It is a memory without intention, yet full of truth. Perhaps this is why light feels sacred. It allows us to participate in the universe's history, not from books or legends, but directly from the source. It grants access to epochs we never lived, places we never traveled, worlds we never imagined. It is the most honest historian, one that records without bias, without narrative, without error. To behold light is to receive time. To understand light is to understand the continuity of existence. And when we close our eyes at night, drifting into stillness, the photons that touched us linger subtly in memory. They remind us that even in the quiet darkness of our minds, we are connected to a vast unfolding of time. The past is never fully gone. It is always arriving. Through light, the universe continues to remember and invites us to remember with it. Light is silent, but its silence is not emptiness. It is language without sound, a conversation carried across the universe in the quietest possible way. We often think of speech as the only form of communication, but long before tongues evolved, long before ears learned to hear, light was already speaking. It spoke through color, through temperature, through the delicate shifts in wavelength that reveal the conditions of its birth. It spoke through direction, telling where it came from. It spoke through persistence, telling how far it has traveled. Light is the original storyteller, whispering across distances so wide no voice could cross them, preserving messages long after their sources have faded. We often imagine that communication requires intention, but light teaches that meaning does not need desire. It only needs presence. A star does not choose to speak, yet its radiance carries news of its heart, the heat of its core, the elements it forges, the speed of its rotation. All these truths are encoded in the photons it releases. They scatter outward, reaching anyone prepared to listen. When life arises, when eyes open, the message is received. But even without a watcher, the message continues, patient and complete. Every photon is a tiny courier, carrying its information effortlessly. It travels with no memory of its journey, yet it preserves the memory of its origin. When it brushes our instruments or touches our vision, it gives us a glimpse into a moment long past. A single beam of starlight can tell a complete story. How hot the star is, what elements it contains, how quickly it spins, whether it is moving away or approaching. Scientists have learned to translate these silent messages, reading color as temperature, spectral lines as chemistry, motion as the shifting of wavelengths. Through these subtle inflections, stars share their biographies without a word. To think of light as communication is to imagine the universe as a vast network of quiet messages. Every star sends out continual waves, announcing its existence. Every galaxy, every nebula, every pulsing remnant of a dying sun contributes to this ongoing dialogue. The cosmos is filled with these transmissions, overlapping and interwoven. In their totality, they form a subtle chorus, a harmony not meant for ears, but still rich with meaning. This communication is unbiased. Light does not single out one observer over another. It does not favor one direction. Its messages are broadcast endlessly equally, to every region of space. Anyone, anywhere, who develops the capacity to perceive can listen in. Light is the most democratic of storytellers, offering its truth freely to all. There is poetry in the way light carries its stories. It does not force itself upon space. It simply expands, radiating outward until something meets it. For every photon that enters an eye, trillions more continue traveling, unfazed by the absence of an audience. Their message is not for someone, it simply is. Communication without expectation. Even the colors of light are a kind of vocabulary. Blue remembers heat and youthful intensity. Red recalls cooling and distance, the expansion of space stretching its memory. Between them lie every subtle shade, each one carrying a unique inflection, a nuance in the narrative of its source. Just as languages encode emotion and identity, wavelengths encode the inner lives of stars. When light interacts with matter, it leaves delicate traces. It can energize particles, warm surfaces, change direction, or vanish into absorption. These interactions become part of its ongoing message. A photon passing near a massive object will bend, not because it wishes to, but because space itself curves around matter. This bending becomes a record, telling us of invisible forces and unseen masses. Without light, gravity would be mute. Space would be without witness. This reflective dialogue is not limited to the stars. Objects closer to home, planets, dust clouds, drifting worlds, all participate. They absorb, reflect, and scatter light, modifying its story. A planet's color tells of its atmosphere. A moon's brightness reveals its surface. Even a cloud of interstellar dust can alter a photon's path, adding to the memory it carries. Thus, every journey light makes adds new chapters to its story. We, with our fragile eyes, are listeners standing at the edge of an ancient conversation. When we raise our gaze to the night, we are not merely seeing, we are receiving. Our minds translate what they can, turning wavelengths into images, impressions, feelings. Some messages we interpret scientifically, some we interpret emotionally, but all remind us of our place within a universe that is forever speaking. There is a special intimacy in knowing that when we lie beneath the stars, we are bathed in messages billions of years old. Light that falls on our skin tonight may have been released when the first forest arose on Earth. Other rays may have begun their journey even earlier, when the galaxy was young, when our solar system was not yet imagined. To receive these messages is to be part of a continuity that stretches beyond the limits of human time. Even within darkness, communication persists. What appears empty is rarely void. Photons too faint for the eye still drift, forming a quiet background. Radio waves slip through space. Infrared warmth whispers of dust and unseen stars. These subtle signals weave a tapestry of information, hidden beneath the threshold of ordinary perception. With sensitive instruments, we can tune to these frequencies, hearing conversations that would otherwise remain silent. Perhaps this is the essence of cosmic communication. Nothing is truly isolated. Every object, every event, every particle broadcasts its story. Light is the universal medium of remembrance, reaching outward endlessly. The universe is filled with quiet voices, all carried by the same gentle, ancient messenger. And so, when we think of communication, we might remember that the deepest exchanges do not require sound or intention. Sometimes, the most profound messages are those that simply exist, waiting for awareness to awaken. Light, with its silent testimony, reminds us that the universe is always speaking, gently, continuously, and that every moment we choose to look is a moment we choose to listen. Light does not merely illuminate, it encodes. Every photon is a tiny messenger, a vessel carrying precise information about its origin, its journey, and the transformations it has experienced along the way. In its color, in its frequency, in the subtle shifts caused by distance and motion, light whispers secrets of the universe, written in a language older than thought itself. And though it travels silently, without sound or intention, the information it bears is profound, a testament to the intimate relationship between existence and perception. When a star burns, it does more than radiate energy. It broadcasts its essence. The elements forged in its core, the intensity of its heat, the subtle pulsations of its rhythm, all leave an imprint on the light it releases. Each photon becomes a precise record of these conditions, an undistorted memory of what was. The universe, in this sense, has a library not of paper or ink, but of radiance. And every observer, whether human or machine, becomes a reader, decoding the information carried across the vast distances of space. Even phenomena that seem ordinary, like the gentle glow of a distant galaxy, contain layers of meaning. The tilt of its spiral arms, the distribution of its stars, the faint presence of gas clouds all influence the light that reaches us. By measuring these subtle variations, we can reconstruct the galaxy's history, understand the forces that shaped it, and trace the dynamics of its evolution. Light, in essence, is a medium through which the universe preserves its own biography, a subtle archive traveling at the fastest speed in existence. Consider how scientists study starlight to reveal secrets that would otherwise remain invisible. Through spectroscopy, they dissect the light into its component colors, uncovering the fingerprints of chemical elements. Each absorption line, each tiny dip and spike, is a story, the presence of hydrogen, the trace of iron, the signature of oxygen. Through careful observation, we can determine the age of stars, the composition of planets, and even detect worlds light years away. It is astonishing to realize that photons, which were born billions of years ago, still carry the capacity to inform us about distant pasts, about events that unfolded long before our own eyes could see. And yet, the message of light is not solely scientific. It is also poetic. The way it bends around masses, refracts through clouds, and scatters across dust-laden regions adds layers of subtlety, a form of expression that speaks to the imagination as much as the intellect. Light is the universe writing in a language that transcends words, a narrative encoded in the very structure of reality. Each wavelength, each hue, each oscillation is part of a symphony that carries both factual truth and aesthetic resonance. Even the smallest shift in light's journey can carry profound information. When photons pass near massive objects, their paths curve, tracing the contours of invisible gravitational wells. By observing this bending, we can map the unseen forces that shape the cosmos. Light preserves the memory of these interactions, silently recounting tales of stars that have long since vanished, of black holes that continue to distort space, of matter that cannot be seen directly. In this way, light becomes both historian and storyteller, chronicling what exists and what no longer does. The precision of light's memory is remarkable. Unlike other forms of recording, which degrade or fade, photons maintain their intrinsic information across incomprehensible distances. Time stretches around them, but they carry intact the conditions of their birth. Even when redshifted by the expansion of space, they reveal the universe's growth, offering insight into the very fabric of reality. Every photon is a note in an unbroken composition, echoing the universe's unfolding story with unwavering fidelity. Yet the language of light is not always readily interpreted. It requires a mind, a consciousness, an instrument capable of translating its subtle cues into understanding. In this way, light and perception are intertwined. The universe remembers, but it becomes conscious of its memory only when there is a being capable of reception. Observation, therefore, is not a passive act. It is participation in a cosmic dialogue, a collaboration between memory and awareness. Even phenomena closer to home demonstrate light's capacity to encode. Reflected sunlight tells of planetary atmospheres, the textures of surfaces, the presence of clouds or ice. The faint glimmer of radio emissions from human technology now drifts outward, an unintentional archive of our own civilization. Every signal we send, every reflection we create, becomes part of the luminous record, traveling beyond Earth, joining the chorus of ancient photons that have always carried the universe's memory. The universality of light's communication is profound. It knows no borders, no species, no geography. Its messages are open to all who can perceive them. From the first star to the newest civilization, from the simplest photon to the most complex human instrument. light connects everything. It is a silent web of information, linking matter and energy, past and present, observer and observed, in an unbroken continuum. Perhaps the most extraordinary aspect of light's role as messenger is its endurance. It travels ceaselessly, crossing voids that seem impossibly vast, surviving interactions without losing the essential truth it carries. It preserves memory in a form that is both elegant and resilient, capable of spanning billions of years and unimaginable distances. Through this endurance, the universe ensures that its own story is never entirely lost, that its history continues to unfold in the eyes of those who look, in the instruments that measure, and in the consciousness that interprets. And so, as we contemplate light in its quiet brilliance, we are invited to consider not only what it reveals about the universe, but what it reveals about memory itself. In every beam, every ray, every subtle variation, light preserves the essence of its origin. It transforms experience into record, existence into testament. To watch, to listen, to perceive is to participate in this remarkable process. In this way, light is not merely energy, it is remembrance. It is the universe holding itself, reflecting on itself, telling its own story across the vast and silent corridors of space. Stars are not merely points of light scattered across the night sky. They are luminous archivists, cosmic storytellers whose histories are etched into every photon they release. Each star burns with a particular rhythm, temperature, and composition, and these qualities shape the light it emits. In this way, stars become the authors of their own chronicles, recording the unfolding of nuclear reactions, the forging of elements, and the intricate dance of matter over millions or even billions of years. Every flicker, every pulse, carries a message from the depths of time, waiting for an observer capable of reading it. When a star ignites, it does so as both creator and witness. Its fusion processes convert hydrogen into helium, releasing energy that will radiate outward for eons. In doing so, the star becomes a conscious keeper of events, even if it possesses no mind. The energy it emits is a record of its inner state, an immutable diary of its existence. Even as the star ages, expands, or collapses, its light continues to convey the narrative of its life. From birth to death, from subtle flares to catastrophic explosions, every photon is a chapter, every wavelength a sentence in a story that stretches across the cosmos. Consider the quiet endurance of a main-sequence star like our Sun. For billions of years, it burns steadily, emitting light that sustains planets, nurtures life, and carries its own history outward into space. That light is a continuous message, one that does not diminish with time. The Sun's photons drift through space, passing worlds, drifting through interstellar clouds, and eventually reaching distant observers. Each carries information about the star's temperature, its chemical makeup, the gentle variations in intensity that reveal its pulsations. Even in its constancy, there is narrative. Even in its steady glow, there is the pulse of memory. Massive stars, those that live fast and die young, create a different kind of story. Their lives are brief, intense, and full of drama. When they explode as supernovae, they scatter their enriched matter across galaxies, seeding the next generation of stars and planets. The light emitted during these final moments is extraordinary, a concentrated expression of a life lived fully. The photons escaping this cataclysm carry the signature of creation and destruction alike, a testament to the cyclic nature of existence. Even after the star ceases to exist in its original form, its light continues, ensuring that its story is not erased, but carried forward across space and time. Stars do not exist in isolation. They form clusters, galaxies, and systems that interact over cosmic scales. As their light travels, it weaves through interstellar dust, gas clouds, and the gravitational contours of the universe. Each encounter leaves a subtle mark, a slight deflection or scattering that adds depth to the story being carried. The photon's journey becomes more than a record of its star. It becomes a witness to the cosmos itself. In this way, stars are both storytellers and participants in a larger narrative, their light entwined with the memory of all that surrounds them. The colors of starlight reveal additional layers of meaning. Blue stars speak of youth and intensity, red stars of maturity and fading energy. Variations in brightness indicate rotation, flares, or magnetic activity. By observing these signals, astronomers can reconstruct the history of a star with astonishing precision. Yet beyond the technical interpretation lies a poetic truth. Each color, each flicker, each spectral signature is an intimate expression of a star's life, a story told in the language of light. The universe, through stars, has developed a narrative medium that transcends time and space. Even when a star dies, its legacy endures. White dwarfs cool slowly, continuing to emit faint light for billions of years. Neutron stars pulse with precision, sending rhythmic signals that ripple across the galaxy. Black holes, though they consume light, influence the surrounding radiation, bending photons into arcs that encode the presence of the unseen. In each case, the star's memory persists, reshaped but never entirely lost. Its narrative becomes part of the fabric of the universe, a thread in the vast tapestry of cosmic remembrance. To gaze at the stars is to witness the universe's autobiography. Each twinkle is a syllable, each constellation a paragraph, each galaxy a chapter spanning millions of years. The photons that reach us are carriers of intimate detail, documenting processes that would otherwise remain invisible. By observing them, we do more than see. We read, we listen, we understand. The night sky becomes a library, a vast archive of events written in a medium that has existed since the earliest epochs of creation. There is a profound intimacy in this realization. When starlight touches our eyes, we are not merely passive observers. We are participants in a narrative that began long before humanity existed. We become part of the story we are reading. The universe is telling its tale, and we are attuned enough to perceive it. Through the stars, the cosmos remembers itself, and in perceiving that memory, we contribute to the act of remembering. Consciousness, fleeting and delicate, becomes a link in a chain of cosmic continuity. Stars, in their quiet persistence, remind us that memory need not be conscious to be profound. Their light is a testimony to existence, a record of energy transformed into matter, of time endured, of creation observed. Each photon is a silent witness, carrying the story of a star's life across unfathomable distances. And when those photons reach us, they do more than illuminate. They connect us to a cosmos that is at once ancient, vast, and deeply aware of its own history. In this way, stars are not simply celestial objects. They are storytellers, historians, archivists of the universe, encoding the passage of time into every beam, every color, every flicker of light that drifts across the night. And through them we too become part of the story, readers of a narrative that began long before we were born and will continue long after we are gone. Galaxies are not simply collections of stars. They are living archives, sprawling cities of light and memory that drift slowly through the universe. Within each spiral arm, within every luminous cluster, the histories of countless stars intertwine. Each photon traveling from these distant realms carries not only the story of its star, but also the tale of the galaxy itself, the interactions, the collisions, the silent dances of gravity that have shaped it over billions of years. To observe a galaxy is to witness an immense, layered narrative unfolding, one that has no beginning in human time, no end in human understanding. The paths light takes from galaxies are not straight. Gravity, that invisible sculptor of space, bends the journey of photons, curving their routes as they pass massive objects. Light, in this sense, does not merely transmit memory. It encodes the presence of what cannot be seen directly. A distant galaxy's glow can be stretched, refracted, or magnified by intervening matter, revealing structures hidden from the naked eye. In this way, light becomes both storyteller and cartographer, mapping the invisible forces that shape the cosmos, preserving a memory not only of matter, but of its motion and the unseen energy it traces. Within galaxies, the interplay of stars, gas, dust, and dark matter creates a symphony of light. New stars ignite in clouds of hydrogen, casting their glow onto surrounding nebulae. Older stars drift toward the edges, cooling, reddening, their light carrying the quiet testament of a life fully lived. Supernovae erupt, scattering enriched material across the galactic canvas, their brilliance traveling for millions of years before arriving at distant eyes. Every photon born from these events carries a history of the forces that shaped it, of the environment it traversed, and of the unseen companions it passed along the way. Dark matter, though invisible, leaves its imprint through light. As galaxies rotate and cluster, the gravitational influence of this hidden substance bends the paths of photons, subtly altering their arrival. By measuring these shifts, we can infer the presence of something that eludes direct detection, revealing that the universe's memory extends beyond the visible. Light does not merely record, it interprets, holding within it the echoes of structures we might otherwise never perceive. The very shadows of existence are preserved in its journey. When we gaze at a galaxy, we are witnessing an enormous archive of interactions. The oldest stars near its center tell of early formation epochs. The youngest stars in the spiral arms reveal ongoing processes of creation. Clouds of gas, illuminated by neighboring stars, indicate regions where new life might eventually emerge. Through careful observation, astronomers can reconstruct the galaxy's history, which mergers occurred, which bursts of star formation shaped its structure, and how its gravitational dance with neighboring galaxies altered its path. Light is the messenger that makes all this possible, faithfully carrying billions of years of information across the void. Even the faintest glimmers of intergalactic light hold stories. Photons that have wandered for millions or billions of years, unabsorbed and uninterrupted, arrive as soft whispers from the depths of time. Their faint glow reminds us that galaxies are not isolated. They exist within a web of cosmic connections, interacting subtly through gravity, tidal forces, and the exchange of material. Light preserves these interconnections, ensuring that the memory of every encounter, every near miss, every subtle influence is carried forward across the expanse of space. There is a gentle rhythm to this cosmic storytelling. Galaxies grow, collide, and settle into new forms over unimaginable timescales. Their light records this evolution, documenting changes imperceptible to the human lifespan, yet monumental on cosmic scales. The rotation of a spiral, the swelling of a star cluster, the dispersal of a dying supergiant, all are encoded into the photons traveling outward. Each journey is unique, carrying a distinctive signature, a detailed biography of a galaxy's life and the countless stars it nurtures. Through this luminous record, the universe remembers itself. Each galaxy, with its sprawling arms and dense cores, acts as a memory node, storing and transmitting information about the past. Even when galaxies collide, as they frequently do, their light merges, intertwining histories in a grand cosmic choreography. Future observers, millions of light years away, will receive the fused message, deciphering layers of memory spanning multiple civilizations of stars. Light preserves continuity, even through chaos and transformation. As we contemplate the night sky, the galaxies we perceive are not merely distant objects. They are living histories, eternal storytellers whose light has traversed time to reach us. They carry within them the memory of their stars, the record of their formation, and the traces of interactions both seen and unseen. To witness a galaxy is to witness a vast chronicle, a poetic archive composed entirely of photons, each one a messenger from a past we could never otherwise encounter. Even as human consciousness fades into sleep, these galaxies continue their quiet dialogue. Their light continues to travel, silently encoding the events of billions of years. They speak without words, preserving the memory of the universe in a language of color, motion, and persistence. And through their photons, the cosmos reminds us that memory is not limited to minds or cultures. It is woven into the very fabric of existence, traveling endlessly, waiting for eyes capable of reading it. Nebulae are the universe's living canvases, vast clouds of gas and dust where creation and memory intertwine in ways both delicate and profound. They are the wombs of stars, the cradles of new light, and yet they themselves are ancient repositories of cosmic history. Within these clouds, photons travel slowly, weaving through matter that absorbs, scatters, and re-emits them, carrying with each interaction the imprint of its environment. In their glow, we witness a record of processes that span millions of years, regions of collapse, turbulence, ignition, and quiet, all preserved in shifting wavelengths that journey across space to reach us. The colors of nebulae are not mere decoration. They are the language of memory made visible. Hydrogen glows with soft reds, the most abundant element recording the fundamental building blocks of the cosmos. Oxygen glimmers in emeralds and blues, a delicate signature of complex chemistry taking shape over eons. Sulfur pulses with deep crimson, tracing pockets of energy where collisions of matter create warmth and light. Each hue is a letter, each gradient a phrase, describing the past interactions of particles, the presence of intense radiation, and the forces that have shaped these clouds into forms both chaotic and sublime. Within nebulae, new stars emerge from collapsing regions, and each photon emitted in these moments is a newborn message, carrying the memory of the collapse, the density of the surrounding gas, and the temperature of the ignition. These newborn stars illuminate the surrounding cloud, and in doing so, they create secondary light that is itself a messenger of memory. The entire nebula becomes a symphony of layered narratives, each photon a verse, each reflection a refrain, preserving events that no other observer could witness directly. The slow diffusion of light within a nebula amplifies its role as a memory keeper. Photons are absorbed and re-emitted countless times before escaping into the wider universe, each interaction encoding subtle details of the cloud structure. The diffuse glow we eventually observe is not simple or uniform. It is a composite record, a layered chronicle of the nebula's density variations, magnetic fields, and energetic processes. In this sense, the light we see is a meditation on the nebula's history, a faithful transcript of its internal life. Nebulae also serve as bridges between generations of stars. Supernova remnants, for example, expand and illuminate surrounding clouds, depositing enriched elements that will seed future stars and planets. The photons born in these interactions carry traces of both the original explosion and the medium through which they pass, creating a nested memory. Every new generation of light preserves the echoes of those that came before, and through this continuity, the universe maintains a record of cycles that repeat over vast timescales. The interplay of light and shadow within a nebula speaks of contrasts fundamental to understanding memory itself. Dense regions obscure, absorbing photons and holding them longer, delaying their release by hundreds or thousands of years. In doing so, they preserve a moment, a localized record, before passing it outward. Less dense regions allow light to escape more freely, conveying events more directly. The nebula thus becomes a natural editor, shaping the narrative with both patience and variation, recording some moments in intricate detail, while letting others drift quickly into the larger cosmic archive. Dust within nebulae plays a subtle but essential role. Tiny grains absorb ultraviolet radiation, heating slightly before re-emitting it in the infrared. Each absorbed photon leaves an imprint, and each re-emitted photon carries forward this encoded memory. Light in this way becomes a carrier not just of information, but of transformation, preserving not only what was, but how it was changed by its environment. Through dust and gas, the universe remembers itself in an intimate, almost tactile way, registering the physicality of space and matter alongside the chronology of events. Nebulae are also laboratories of probability, where photons interact in countless permutations before escaping. The slight deflections, the scattering, the absorption, all of these are forms of cosmic notation. A single photon leaving a nebula carries within it a detailed record of its meandering path, a story of interactions so complex that it can never be perfectly reproduced. Yet it retains the essence, the signature, the memory of its passage. In this, nebulae teach that memory is not static. It is shaped by the journey, by every encounter along the way. The ancient light we receive from nebulae is therefore not a simple snapshot. It is a layered chronicle, a record of transformation, interaction, and creation. When we observe the Orion Nebula, the Eagle Nebula, or the Carina Nebula, we are not merely seeing gas and dust illuminated. We are reading a manuscript written in photons, a meditation on the cycles of matter, energy, and light. Each color, each flicker, each gradient of glow is a sentence in a story that has been unfolding for millions of years. As we contemplate these clouds from the quiet of our own night, perhaps lying in stillness before sleep, there is comfort in the continuity they embody. Light within nebulae preserves memory across unimaginable distances and timescales, carrying with it the intimate record of creation itself. Every photon that eventually brushes our eyes is a messenger, a bridge connecting us to events long past, to processes that have sculpted the cosmos, to histories that continue beyond our immediate perception. Through these clouds, the universe teaches us that memory is not merely a human trait. It is woven into the fabric of existence, moving silently, patiently, across the endless expanse of space. Planets are not merely spheres of rock, gas, or ice drifting through the void. They are repositories of memory, slow archivists of cosmic events and environmental transformations. Each one carries within it the history of its formation, the collisions that shaped it, and the subtle influences of the star it orbits. Even the faintest glimmers of reflected starlight preserve information, the composition of its surface, the structure of its atmosphere, the traces of volatile interactions over billions of years. In this sense, planets are living records, silently chronicling the interplay between matter, energy, and time. When light strikes a planet, it interacts with surfaces and atmospheres in ways that encode memory. A photon, reflected from a mineral-rich surface, carries information about the elements it encountered. A photon filtered through a gaseous atmosphere bears traces of absorption lines, revealing chemical composition, pressure, and temperature. The tiny shifts in wavelength, the subtle scattering caused by clouds, aerosols, or ice, all contribute to a record that can be read with patience and sensitivity. Light becomes both a messenger and a historian, translating the planetary environment into observable memory. The process of planetary memory is cumulative and subtle. Crusts grow and erode, oceans ebb and flow, atmospheres form and dissipate. Every event leaves a signature in light. A volcanic eruption might coat a planet with reflective ash, altering the spectrum of light that escapes into space. A massive storm might shift the balance of gases, changing absorption patterns. Even seasonal cycles are recorded, with shifting albedos marking the passage of time. Every photon escaping the planet carries fragments of this history, a cumulative story of geological, chemical, and climatic evolution. Beyond their physical surfaces, planets interact dynamically with their stars, embedding additional layers of memory in the light they reflect. Variations in stellar radiation, solar flares, and the subtle oscillations of a parent star influence the photonic signature of the orbiting world. The tilt of an axis, the length of a year, the shifting patterns of magnetic fields. All these factors modulate the light that eventually travels into interstellar space. Through this, planets become translators, converting the life and rhythm of their stars into tangible, measurable phenomena. Planets also preserve the memory of cosmic events beyond their immediate star system. Impacts from asteroids, comets, or interstellar objects leave scars, both physical and photonic. When light interacts with these scars, it carries the record outward, encoding events that may have occurred billions of years ago. Craters, dust layers, and ejecta all affect reflectivity, spectral signature, and even thermal emissions, allowing future observers to reconstruct the violent history of the world. Planets, in this way, act as natural time capsules, holding the evidence of processes that shaped their surfaces and environments long before conscious beings existed to witness them. The interplay between light and planetary memory extends to life itself, when present. Vegetation, microbial mats, and photosynthetic activity subtly influence the color and reflectivity of a planet, leaving detectable fingerprints in the light that escapes into space. Seasonal growth and decay cycles introduce temporal patterns. Changes in atmospheric chemistry caused by respiration or decay are reflected in absorption lines. Even without sentient observers, planets with life encode the rhythms of living systems, transforming them into legible photonic signals that travel across the cosmos, preserving the memory of organic activity. Planetary memory is patient, enduring, and cumulative. Unlike the fleeting radiance of a star or the scattered brilliance of a nebula, planets store their histories in slower, subtler ways. Their surfaces and atmospheres change incrementally, layer by layer, recording events over millions or billions of years. Light interacts with these histories, gathering them in quiet accumulation, until a single photon emerges carrying a rich, detailed record of the world it has encountered. Through this, the universe preserves planetary memory in a form accessible to those who know how to read it. When humans observe planets, whether within our solar system or beyond, we are engaging with these archives. Spectroscopic measurements, albedo studies, and thermal imaging allow us to reconstruct the histories encoded in reflected and emitted light. We can infer the presence of water, detect storms, and even anticipate chemical reactions long in progress. In doing so, we become readers of a cosmic library, decoding the narratives that photons have carried faithfully for eons. The planets are silent teachers, offering insight not through speech, but through the careful transmission of information embedded in light. Even seemingly lifeless worlds carry profound memories. Mercury's scarred surface speaks of ancient bombardments. Mars preserves the whisper of flowing water and vanished rivers. Icy moons reveal frozen archives of tidal forces and chemical reactions. Each photon escaping these worlds carries fragments of these events, a testimony to processes that occurred long before conscious minds could observe them. Memory, encoded in light, is the planet's enduring voice, allowing the universe to remember itself through the slow but deliberate actions of matter. Ultimately, planets teach us about the universality of memory. From the smallest rock to the largest gas giant, from barren desert plains to oceans teeming with microscopic life, they preserve a record of existence in the photons they release. Every beam of light that reaches distant eyes or instruments carries fragments of this memory, bridging gaps in space and time. Through them, we learn that memory is not exclusive to life or mind. It is a property of existence itself. Light allows the universe to remember, and planets serve as its patient, enduring scribes, encoding events and processes that will continue to resonate across the cosmos long after their immediate surroundings have changed. Moons, though often overshadowed by the brilliance of stars and the complexity of planets, are guardians of subtle memory. They orbit, they reflect, and they record, quietly preserving traces of cosmic history in the light they emit and the patterns they impose on their parent planets. A moon is not merely a satellite. It is a witness, a chronicler of tidal forces, orbital shifts, impacts, and even the subtle interplay of its planet's atmosphere with starlight. Each photon bouncing off its surface carries a story, sometimes ancient, sometimes ongoing, yet always part of the greater memory of the solar system. When light touches a moon, it interacts with surfaces that are often untouched by atmosphere, preserving the delicate imprint of cosmic events in its reflection. Craters tell of collisions with asteroids and comets, scars left by moments of sudden violence. Dust and regolith record micrometeorite impacts over millennia. Even the faintest variations in surface composition, invisible to the naked eye, influence the spectrum of reflected light. Each photon escaping the moon carries these signatures outward, conveying a detailed history of events long past and energies long dissipated. In this way, moons act as archivists, preserving the traces of both local and interplanetary memory. Tidal forces between moons and their parent planets create rhythms that leave subtle imprints on both bodies. The push and pull of gravity causes shifts in orbital patterns, surface flexing, and internal heating. These mechanical influences manifest in measurable ways, affecting how light is absorbed and reflected. The photons traveling from these moons bear evidence of these rhythms, encoding the dynamic interactions between celestial bodies. Moons, in this sense, become storytellers of forces that are invisible to human senses, their light translating gravity into narrative. Some moons, particularly those with thin atmospheres or subsurface oceans, add another layer to this memory. Gaseous emissions, reflective ice, and even faint plumes of water or organic molecules interact with starlight, altering its characteristics. Spectroscopic measurements reveal these features, allowing us to infer the presence of chemical activity, tidal heating, or potential habitability. Every photon is a messenger carrying the accumulated memory of environmental conditions, chemical reactions, and subtle internal processes. These moons, though silent, preserve the biography of their own evolution. Impacts are especially poignant moments in a moon's memory. When a comet strikes, it leaves both immediate and lasting effects, new craters, ejecta clouds, and temporary changes in reflectivity. The light interacting with these alterations records the event for future observers. Even long after the impact itself has faded, the photon's journey continues to carry evidence of the collision, a memory that can reach eyes far away, preserving the drama of a single instant within a continuum of cosmic time. Phases of moons introduce an elegant, cyclical form of memory. As they orbit, the changing angle of sunlight creates rhythms in illumination, shadows, and reflections. The waxing and waning we observe from Earth are not merely aesthetic. They encode orbital geometry, orientation, and the timing of motions. Through these cycles, moons preserve a temporal record, a repeating archive of movement that can be measured, predicted, and analyzed. Each cycle is a living record, and each photon escaping during these phases contributes to the ongoing story of the satellite's life. Even the faint glow of moons in the night sky is rich with history. When we gaze at the moon or the distant Galilean satellites, the photons reaching our eyes have traveled across space for minutes or hours, carrying subtle clues about surface composition, reflectivity, and environmental conditions. Ancient lava flows, highlands, lowlands, and craters all subtly affect the light, providing a record of geological processes, sometimes billions of years old. Light thus becomes a bridge connecting human perception with a slow, patient memory of these worlds. Moons also preserve indirect memories of their planets. By reflecting starlight filtered through a planet's atmosphere, or by responding to electromagnetic and tidal forces, moons encode information about their parent bodies in their light. Observing them allows us to infer details about planetary composition, rotation, magnetic fields, and atmospheric changes. The moon becomes a secondary archivist, translating complex planetary processes into a form that can travel across space and be interpreted far away. The quiet endurance of moon's light is perhaps most striking. Unlike stars, which burn intensely and may fade quickly, or planets, which slowly transform over millions of years, moons often preserve the memory of events with minimal alteration. Their surfaces are relatively stable, their histories encoded in textures, reflectivity, and light that drifts outward unchanged for vast distances. Photons leaving these surfaces carry the subtle truth of millions or billions of years, whispering the story of impacts, tidal forces, and the ongoing dance with their planets. To contemplate moons is to contemplate continuity. They teach that memory does not require awareness or intent. It requires only stability, persistence, and the capacity to interact with light. Every photon escaping a moon's surface, whether it illuminates a crater or schemes across ice, becomes a messenger of the past. Through them, the universe preserves its quiet history, layer by layer, orbit by orbit, moment by moment. Moons, with their patient cycles and reflective surfaces, remind us that even in silence, memory endures, traveling outward across space to convey the ongoing story of existence. Comets are travelers of memory, emissaries from the outer reaches of the solar system that carry within them the remnants of creation itself. Unlike planets or moons, they are transient, moving along elongated orbits that take them on epic journeys across the cosmos. Their icy nuclei and dust-laden tails preserve material from the earliest epochs of the solar system, long before Earth had even formed. Each comet is a time capsule, a compact archive of primordial conditions, containing elements, molecules, and isotopes that tell the story of the universe's youth. When light interacts with them, it carries forward these ancient records, translating frozen memory into radiant communication. As a comet approaches a star, its frozen core begins to sublimate, releasing gases and dust into space. The interaction of sunlight with this material creates a luminous tail, a brilliant display of both reflection and emission. Each photon in this tail carries information about the comet's composition, the dynamics of its release, and the effects of radiation and solar wind. In this moment, the comet becomes both spectacle and historian, encoding in its light the environmental conditions it encounters and the intrinsic properties of its primordial material. Even after it recedes into the darkness, the memory of this interaction travels outward, preserving a record of a brief yet significant cosmic event. The trajectory of a comet is itself a narrative of gravitational memory. Their paths are shaped by the pull of planets, the subtle influence of passing stars, and the large-scale structure of the solar system. These interactions bend, accelerate, and sometimes eject comets entirely from their original regions. Light reflecting from a comet is subtly modulated by these journeys, carrying encoded evidence of the gravitational landscapes it has traversed. In this sense, a comet's light is a map of movement and force, a record of cosmic interactions that can only be understood with careful observation. Comets also preserve chemical memory in unique ways. The ice within them holds water, carbon compounds, and organic molecules, all of which are sensitive to the radiation they encounter as they travel inward. When sunlight excites these molecules, photons are emitted at specific wavelengths, revealing the chemical identity of their source. Each emission line is a letter in the story of the comet's composition, a whisper from the earliest era of planetary formation. Through these photons, the universe communicates the presence of matter that predates the formation of life on Earth, linking past and present in the quiet glow of a traveling tail. The tails of comets are particularly remarkable in how they preserve temporal memory. Dust and gas are released at varying rates depending on proximity to the star, rotational orientation, and internal structure. This creates a layered archive in the tail itself. Older material trails behind. Newer emissions extend forward. The light scattered and emitted by these layers carries with it a chronological sequence, a record of the comet's gradual evolution as it journeys through the inner solar system. Each photon that escapes becomes a messenger of process, a detailed account of the interaction between primordial matter and stellar energy. Even the dimmest comets hold stories of environmental change. Their surfaces are marked by countless encounters with radiation, micrometeoroid impacts, and thermal stresses over billions of years. Photons reflecting from these surfaces carry evidence of such alterations. Subtle shifts in reflectivity, slight variations in spectral lines, and faint emissions of trapped gases. Every journey of light encodes the memory of these interactions, silently transmitting the history of resilience, transformation, and survival across the void of space. Comets are also bridges between distant worlds. When their tails intersect planetary atmospheres or interact with magnetospheres, new light patterns are created, recording the passage of matter from one body to another. Tiny particles from comets can seed planets with water or organic compounds, their interaction leaving subtle traces in the reflected light. In this way, a comet's light not only preserves its own memory, but also becomes a carrier of environmental influence, linking different regions of a solar system in a network of luminous testimony. The observation of comets has historically inspired awe, but their deeper significance lies in their role as conveyors of memory. Their photons are both witnesses and messengers, traveling vast distances to carry information about composition, motion, and interaction. When we study a comet through telescopes and spectrographs, we are engaging in a dialogue with the universe, reading the encoded record that has traveled billions of kilometers, preserving the conditions of a time and place far beyond our immediate perception. In the quiet of night, as a comet arcs across the sky, its tail glowing faintly, we are touching a lineage of memory that predates humanity. Every photon leaving that tail has a history of ice formed in the outer solar system, of dust gathered from interstellar space, of radiation absorbed and emitted over millennia. Through this delicate, luminous record, the universe remembers its own origins, and we, in our momentary presence, have the privilege of receiving that memory. Comets, in their transient beauty, remind us that memory need not be permanent in location to endure an effect, and that light itself is the ultimate archivist, preserving the earliest whispers of the cosmos for any who can perceive. Asteroids are the quiet chroniclers of the cosmos, fragments of rock and metal that drift through space like pages torn from the earliest chapters of the solar system. Unlike the luminous stars or reflective moons, asteroids often appear dim and unassuming, yet each carries within it a remarkable record of formation, collision, and alteration. Every photon that interacts with their surfaces is subtly encoded with the memory of these processes, creating a silent archive of chemical composition, thermal history, and cosmic impact. In their stillness, they preserve stories that may predate the planets themselves. The surfaces of asteroids are littered with scars from countless collisions, both gentle and catastrophic. Each impact leaves traces, craters, fractures, and scattered debris that subtly influence the way light reflects or absorbs. Photons that bounce off these features carry with them information about the size, speed, and direction of the colliding bodies, as well as the composition of the impacted material. In this sense, an asteroid is both storyteller and historian, its very texture encoding a chronicle of cosmic violence and endurance that travels outward with each particle of light. Asteroids are often considered inert, yet they are dynamic in their own quiet ways. Radiation from the sun slowly alters their surfaces, changing reflectivity, heating unevenly, and occasionally causing small particles to detach. Over long periods, these effects accumulate, leaving detectable fingerprints in the light that escapes. Spectroscopic analysis can reveal not only the elements present, but also the history of exposure, the subtle chemical weathering that has occurred across eons. Each photon leaving an asteroid is thus a messenger carrying both material and temporal memory, a testament to the passage of time in the silent void. The composition of asteroids varies widely, from metallic cores to carbon-rich bodies to silicate rocks. This diversity itself is a record of early solar system processes. Some are remnants of failed planetary embryos, never having coalesced into full planets, preserving within them the chemistry of primordial material. Others are fragments of larger bodies, shattered by collisions, yet carrying the original identity of their parent. Light interacting with these materials encodes their varied histories, allowing observers to reconstruct the architecture and evolution of the early solar system. Each spectral line, each subtle variation in reflectivity, becomes a syllable in the story that asteroids silently tell. Asteroids also act as time capsules of cosmic radiation. Over billions of years, they have been exposed to the relentless bombardment of energetic particles, each interaction leaving a subtle imprint on their surfaces. These irradiated layers influence the absorption and scattering of light, preserving evidence of the environmental conditions that prevailed during their long journeys through space. Every photon reflected carries the echo of these exposures, enabling distant observers to read a record of radiation that has spanned the lifetime of the solar system. Even their orbits contribute to the memory they encode. Asteroids travel in elliptical paths, sometimes perturbed by planetary gravity, sometimes crossing paths with one another. The variations in their trajectories affect the angles and intensity of sunlight they reflect, producing subtle modulations in their light signature. In this way, orbital history is imprinted onto the photons they emit or reflect, providing insight into the dynamical evolution of the solar system. Each journey through space becomes part of their encoded story, transmitted silently through the medium of light. Collisions between asteroids create a secondary memory system. When a large body shatters, its fragments scatter, each carrying part of the original object's material and history. The light reflected by these fragments carries information about both the original body and the energetic event that fragmented it. In this sense, asteroid families are like dispersed chapters of a single narrative, with each piece preserving part of the whole. Observers reading these fragments through light can reconstruct the original history, mapping connections across space and time. Asteroids, in their quiet persistence, remind us that memory does not require consciousness. Their records are physical and photonic, encoded in mineral structure, surface morphology, and the interaction of light. Each photon leaving an asteroid is a tiny archive, a courier carrying the evidence of formation, collision, radiation, and movement. Across the vast distances of space, these messages endure, waiting for someone or something capable of reading them. They are silent witnesses to the processes that shaped planets, moons, and comets alike, preserving a story that is both specific and universal. Even when asteroids drift unnoticed, their light continues to travel. Their humble glow illuminates nothing immediately, yet it preserves information that can be decoded by patient observation. In this quiet persistence, they embody the concept of enduring memory, subtle, indirect, yet remarkably complete. They are cosmic archivists, preserving details too small for a glance, but too important for the universe to forget. Through asteroids, we gain insight into the universe's earliest chapters. Their light is a messenger of primordial conditions, a record of chemical processes, collisions, and gravitational interplay that occurred before the planets fully formed. In every reflection, every absorbed photon, we find a history that stretches across billions of years, linking the present to the distant past. Asteroids remind us that memory can be silent, patient, and enduring, and that light, in carrying these records, transforms mere matter into the chronicler of time, preserving the universe's story in a way that transcends consciousness, intent, and awareness. Meteor showers are ephemeral illuminations, fleeting yet profound, that bring the universe's memory into vivid motion. Unlike the steady light of stars or the enduring glow of planets and moons, meteors are moments of transformation, brief yet intense, marking the intersection of cosmic history with the immediate present. Each streak of light is a traveler burning through a planet's atmosphere, carrying with it the memory of a journey that may have begun millions or billions of years ago. In every trail, every fleeting glow, photons encode the story of origin, motion, and interaction, leaving a luminous record that can be observed, studied, and felt. When meteoroids enter an atmosphere, they experience friction and compression, heating rapidly and producing a brilliant streak visible across the sky. This light is not arbitrary. It is the product of material composition, velocity, and the atmospheric medium through which the object travels. Each photon escaping the burning mass carries information about these factors, encoding a precise account of the event. The fleeting trail of a meteor is, in essence, a momentary archive of physical conditions, transformed into light that bridges the gap between distant space and a planetary surface. Meteor showers often originate from comets, which leave streams of dust and ice along their orbital paths. When a planet crosses such a stream, countless meteoroids enter the atmosphere, creating a cascade of luminous memory. Each particle carries within it the ancient material of its parent comet, frozen and preserved over eons. As these particles ignite, they release photons that encode chemical composition, density, and structural history. The showers become a dialogue between past and present, a poetic manifestation of memory reaching through space and time. Even the smallest meteor, invisible to the naked eye, contributes to this cosmic record. Micrometeorites strike planetary surfaces, embedding themselves in regolith, ice, or water, and subtly altering the reflectivity and emission of photons from the impacted area. In this way, even imperceptible events are recorded in light, creating a layered archive that blends fleeting motion, with enduring consequence. Memory in the universe is not limited to magnitude. Even the smallest interaction can leave a trace, carried outward by photons for countless years. The ephemeral nature of meteor showers also highlights the fragility and intensity of memory. Unlike planets or moons, which preserve long-term history, meteors exist in an instantaneous transformation, yet their light communicates a wealth of information. Each streak is a concentrated burst of cosmic history, a momentary flash that conveys origin, journey, and chemical identity in a few seconds. Observers witness not just beauty, but a condensed archive, a fleeting message that encapsulates millions of years of formation and travel. Meteor showers are also markers of orbital memory. The streams of debris they originate from trace the paths of comets, recording gravitational influences, solar radiation, and past interactions with planets. The timing, frequency, and distribution of meteors are shaped by these orbital histories. Light emitted during these events carries the subtle imprints of these patterns, encoding trajectories, velocities, and variations that reflect a broader cosmic choreography. Each photon is thus a storyteller of both individual and collective history, linking moments across space and time. The colors of meteors further enhance their role as memory bearers. Different elements burn with distinct hues. Sodium glows yellow, magnesium shines white, iron flickers with gold. Each color is a letter in the narrative of composition, each variation a word describing the materials that have existed since the solar system's birth. Observing a meteor shower becomes an act of reading, where colors and brightness translate ancient material into perceptible memory, carried by photons that move across the atmosphere and outward into space. Meteor showers also remind us of impermanence and continuity simultaneously. Each individual meteor is transient, disappearing in moments, yet the showers recur annually, following the orbital path of the parent comet. This cyclical recurrence encodes a rhythm in cosmic memory, a pattern that persists even as individual events vanish. Light in this context is both ephemeral and enduring. A photon may burn briefly in our sky, yet its origin and the history it carries extend far beyond our immediate perception, connecting fleeting experience with long-term cosmic patterns. Even human observers are drawn into this interplay of memory and light. When we watch a meteor streak across the sky, our perception becomes part of the record. The light that reaches our eyes or is captured by instruments is a mediator between cosmic history and consciousness, translating ancient journeys into immediate experience. Meteor showers thus function as bridges between the universe's past and our present awareness, carrying messages that are at once objective, chemical, and profoundly poetic. Ultimately, meteor showers teach us that memory in the universe is multifaceted. It exists in permanence and in momentary events, in slow accumulation and in rapid transformation. Photons are the medium through which all of this memory travels, whether from enduring asteroids or ephemeral meteors. Each streak of light is a fleeting yet precise record of matter, energy, and interaction, traveling across space to bear witness to creation, destruction, and renewal. In observing them, we engage not merely with beauty, but with encoded story of the cosmos, reading a language written in fire, ice, dust, and light, a narrative that reminds us how memory flows endlessly through the universe, carried silently yet vividly in every photon. Auroras are among the most mesmerizing manifestations of cosmic memory, where the interplay of solar wind, planetary magnetic fields, and atmospheric particles transforms invisible energy into shimmering curtains of light. They are ephemeral, delicate, and deeply poetic, yet they encode a wealth of information about the interactions between the sun and planets. Each photon dancing across the polar skies carries a story of charged particles, magnetic reconnections, and atmospheric composition, translating invisible cosmic processes into a luminous language that can be observed and felt. In witnessing an aurora, we are, in effect, reading a chapter of planetary memory written in light. The origins of auroras begin with the sun, whose solar wind, a stream of charged particles, travels millions of kilometers to encounter planetary magnetic fields. These interactions are far from random. Magnetic field lines guide and accelerate particles, funneling them toward polar regions where they collide with atmospheric gases. Each collision excites atoms and molecules, causing them to emit photons at specific wavelengths. These photons carry detailed information about the type of gas, its density, altitude, and the energy of the impacting particles. Through these glowing displays, auroras preserve a record of both stellar activity and planetary response. The colors of auroras are particularly expressive, each hue a signature of chemical interaction and energy exchange. Oxygen emits green and red, nitrogen produces blue and purple, and variations in intensity reflect the velocity and density of incoming particles. Observing these colors is akin to reading a text, with each shade and flicker encoding data about the environment that produced it. The dance of auroras is therefore more than aesthetic. It is a luminous manuscript of cosmic processes, a visual and photonic memory of interactions that might otherwise remain invisible to the human eye. Auroras also carry temporal memory. They vary in intensity and pattern according to solar activity, sometimes flaring in response to coronal mass ejections or solar storms. By analyzing these variations, scientists can reconstruct the history of solar wind events, linking fluctuations in auroral displays to specific moments of solar turbulence. Photons emitted during these events encode the timing, energy, and direction of particles arriving at a planet's magnetic poles. In this way, auroras become a chronicle not only of immediate interactions, but of the broader cycle of stellar and planetary dynamics over days, months, or years. Planetary magnetic fields themselves are preserved in the light of auroras. The shape, structure, and movement of auroral curtains reflect the configuration of magnetospheres, revealing their strength, orientation, and even anomalies. By observing the patterns of auroras, we gain insight into the invisible scaffolding of magnetic fields that envelop planets, creating a record of forces that shape space weather and protect planetary atmospheres. Photons in these displays carry subtle imprints of this guidance, encoding the memory of interactions that extend far above the surface. Auroras are also sensitive to atmospheric conditions. The density, composition, and altitude of gases influence both the color and intensity of the display. Variations in atmospheric pressure, temperature, and chemical abundance subtly modulate the light, leaving traces that can be decoded long after the particles have dissipated. In this sense, auroras are archives not only of solar wind and magnetospheric behavior, but also of planetary atmospheres, preserving a layered history that reflects both external and internal influences. The transient nature of auroras emphasizes the beauty of ephemeral memory. Each display is fleeting, shifting within minutes or hours, yet the photons emitted during the event travel far beyond the planet, carrying their encoded information into space. Even after the light fades from human eyes, the record of energetic collisions, magnetic interactions, and atmospheric conditions continues onward. Auroras, therefore, exemplify the concept that memory can exist in brief, brilliant events, as well as in enduring bodies, and that light itself is the medium through which both persistence and transience are preserved. Auroral phenomena are not exclusive to Earth. Jupiter, Saturn, and other magnetically active planets produce their own displays, each reflecting interactions between solar or planetary particles and gaseous envelopes. By comparing these auroras, scientists can trace universal patterns, differences, and histories, interpreting light to understand magnetic and atmospheric memory on diverse worlds. Photons from these alien auroras travel across vast distances, carrying encoded histories that link planetary behavior to broader cosmic forces. There is also a philosophical resonance in auroras as memory keepers. They illustrate the intimate connection between energy, matter, and light, demonstrating that even invisible forces leave discernible traces. The universe, through charged particles and photons, preserves records of activity that can be observed, interpreted, and felt. Human perception, though limited, allows us to experience these phenomena as both beauty and information, bridging the gap between the abstract processes of the cosmos and the intimate reality of observation. Ultimately, auroras remind us that memory is woven into dynamic processes, as well as static forms. The light that dances across polar skies carries stories of stellar output, planetary defense, atmospheric conditions, and magnetic architecture. Each photon, born from collision and excitation, is a messenger of both cause and effect, journeying outward while preserving the record of its origins. Through auroras, the universe transforms energy into readable memory, ephemeral yet enduring, a luminous testament to the ways in which light allows the cosmos to remember, communicate, and continue its quiet narrative across the expanse of space and time. The cosmic microwave background is the universe's most ancient memory, a whisper of creation itself encoded in light that has traveled for nearly 14 billion years. It is the residual glow of the Big Bang, stretched and cooled over time, yet carrying within it the encoded story of the universe's earliest moments. Each photon is a messenger from a time when space was dense, hot, and opaque, a fragment of a primordial memory that has persisted through expansion, cooling, and the formation of galaxies, stars, and planets. In observing this faint light, we are witnessing the universe remembering its own birth. The photons of the cosmic microwave background have traveled vast distances, interacting rarely but faithfully preserving a record of the early universe. Tiny fluctuations in temperature and density, variations on scales far larger than human comprehension, are imprinted in this light. These subtle differences reveal the seeds of structure, the regions that would collapse to form galaxies, clusters, and the vast cosmic web. Every photon carries a signature of these early conditions, encoding the blueprint of a universe before complexity and life emerged. It is a silent archive, immense in scope and ancient in origin, transmitted to us through light. The patterns within this primordial light are not uniform. Some regions are slightly warmer, some cooler, reflecting density variations that shaped the gravitational landscape. These fluctuations are the fingerprints of the universe's infancy, the initial conditions from which all cosmic evolution followed. Each photon traveling toward us bears evidence of these early imbalances, a memory of how matter and energy were distributed when the universe was still in its formative stage. Light, in this sense, functions as both record and messenger, preserving information that no other medium could convey across such time and space. Observing the cosmic microwave background is akin to reading a vast, ancient manuscript. The faint ripples in temperature and polarization encode the fundamental physics of the early universe. The rate of expansion, the composition of matter and energy, and the processes that governed the transition from simplicity to complexity. Every photon arriving at our detectors carries layers of history, a narrative of how the universe moved from a hot, dense fog to the cosmos we now inhabit. In this, memory and light are inseparable. To observe is to witness the universe, recalling its origins in exquisite detail. The cosmic microwave background also preserves the memory of interactions that occurred after its emission. Photons have passed through evolving structures, including galaxies, clusters, and dark matter filaments. Along the way, gravitational lensing, scattering, and absorption have subtly altered their paths, encoding additional layers of history. Each photon is thus a composite record, reflecting both its primordial origin and the cumulative influence of billions of years of cosmic evolution. The universe remembers itself in a multi-layered archive, with light as its medium. Beyond physical data, this ancient light evokes a sense of philosophical reflection. It reminds us that memory is not limited to consciousness or life. The universe itself retains knowledge of its own beginnings, encoded in the most fundamental interactions of matter, energy, and space. Photons, traveling steadily for billions of years, are both witnesses and messengers, demonstrating that memory can exist on a scale far beyond human perception. Even in the vast emptiness of space, the universe remembers, holding the story of its birth in the persistent glow of these ancient particles. The cosmic microwave background also links all observers across space and time. Every civilization capable of measuring this light, on Earth or elsewhere, receives the same encoded history. It is a universal record, impartial and constant, bridging distances incomprehensible to the human mind. Each photon is a messenger that carries identical information to any observer, preserving a consistent narrative of the universe's earliest epoch. In this sense, the memory of a universe is not fragmented or subjective. It is embedded in the fabric of existence itself, accessible wherever light can be detected. Even the faintest irregularities in this primordial light reveal profound truths. Slight anisotropies and tiny polarization patterns encode information about the physics of inflation, the interaction of matter and radiation, and the fundamental properties of space-time. Each measurement we make allows us to reconstruct the earliest moments of existence with astonishing precision. In every photon, we find a connection to the primordial universe, a tangible thread linking the present to the moment of creation. Memory, encoded in light, spans not just time, but the very structure of reality. The journey of these photons is itself a meditation on endurance. They have traversed an expanding cosmos, moving through regions that would eventually become galaxies, stars, and planets, witnessing the unfolding of space-time without pause. In their constant motion, they carry an unbroken record of the universe's infancy, a message unchanged except by subtle gravitational and electromagnetic effects. Light in its persistence ensures that the memory of the cosmos survives across epochs, waiting to be decoded, understood, and appreciated. Ultimately, the cosmic microwave background teaches us that memory can exist on scales both intimate and unimaginable. Each photon is a record, a messenger, and a witness, carrying the history of creation itself. Through this ancient light, the universe remembers its own origin, encoding the physical, chemical, and structural foundations from which all subsequent cosmic events emerged. In observing it, we participate in a dialogue with the earliest moments of existence, receiving the silent, enduring testimony of a cosmos that remembers itself, and in doing so, discovering that light is the most faithful archivist of all. Black holes are the universe's most enigmatic archivists, paradoxical in their ability to preserve and erase simultaneously. They are regions where space and time curve so profoundly that nothing, not even light, can escape from their core. And yet, they also record indirectly the memory of everything they encounter. Every particle drawn toward a black hole, every photon skimming its event horizon, leaves a subtle imprint on the surrounding space, encoded in gravitational waves, accretion disk emissions, and warped light paths. In this extreme environment, memory takes on forms both physical and abstract, preserving traces of interactions that defy ordinary perception. The accretion disks of black holes, swirling with matter drawn inward, emit high-energy radiation as particles collide and accelerate at near-light speeds. Each photon escaping the disk carries information about velocity, temperature, density, and magnetic interactions. These photons are messengers, transmitting a memory of violent processes that cannot survive intact within the black hole itself. Through them, distant observers can reconstruct the dynamics of matter near the event horizon, reading a record of energy transformation, friction, and angular momentum that has occurred over vast timescales. Gravitational waves provide a subtler form of memory. When black holes merge, they send ripples through space-time, carrying information about mass, spin, and orbital history. Unlike light, these waves traverse the cosmos largely unimpeded, preserving the memory of cataclysmic events across billions of light years. Detectors on Earth, sensitive to these minute distortions, allow us to interpret a narrative encoded not in photons, but in the very fabric of space-time itself. Black holes, in this sense, are storytellers of extremes, their memory embedded in waves that echo the universe's most profound transformations. Even the distortion of light near a black hole's event horizon encodes memory. Gravitational lensing bends photons passing nearby, stretching and twisting the light of background stars and galaxies. Each path traced by a photon carries subtle information about the black hole's mass and spin, preserving a record of its gravitational influence. In this warped light, the universe writes a complex, indirect narrative of presence, influence, and the intricate dance between matter and gravity. Memory here is not static but relational, revealing itself only in the interaction of the black hole with its environment. Black holes also preserve memory in the interplay of matter and radiation over long durations. Matter spiraling in may emit radiation for millions of years before crossing the event horizon. Each escaping photon carries a history of collisions, heating, and acceleration, recording the trajectory and condition of particles long before their final absorption. Even as the matter disappears from observable space, its story survives, encoded in the light that has already departed. In this way, black holes transform annihilation into preservation, turning loss into a chronicled narrative. The paradoxical nature of black holes emphasizes the duality of memory in the universe. They destroy localized information at the event horizon, yet they broadcast global information through emitted photons, gravitational waves, and lensing effects. Memory, in the presence of such extremes, becomes distributed and indirect, illustrating that preservation does not always require physical continuity. Even the most destructive forces can encode the history of interaction, leaving traces readable by patient and perceptive observers. Black holes remind us that memory exists in extremes, in places beyond everyday comprehension, and yet it remains accessible through subtle signals. Photons, waves, and gravitational distortions all serve as carriers, preserving histories that would otherwise vanish. In contemplating these cosmic enigmas, we see that light and its interactions with matter, energy, and gravity are the universe's ultimate archivists, allowing even the most extreme events to leave an enduring mark across space and time.